Number 1, compute the determinant of e2x, 2e3x, 3e3x. So, determinant is equal to top left multiplied to bottom right. So, e raised to 2x times 3e raised to 3x minus bottom left times the top right. So, e raised to 2x times 2e raised to 3x. So, from the law of exponent x raised to m multiplied to x raised to n, we have x m plus n. Therefore, e raised to 2x plus 3x is e 5x 3. So, less e 2x times 2e 3x is e 2e 5x. So, determinant is 3 minus 1, we have e 5x. Number 2, evaluate the determinant of A. So, A is 1, 0, 4, 2, 2, 6, 3, 1, negative 4. Number 2, evaluate the determinant of A. A is 1, 0, 4, 2, 2, 6, 3, 1, negative 4. So, solution. We have expand the minors across the top row. So, here. So, determinant is 1. The sign is positive, negative, positive. So, 1, cover this, 2, 6, 1, negative 4. So, 2, 6, 1, negative 4. Minus 0. We have, cover the middle, we have 2, 3, 6, negative 4. So, 2, 3, 6, negative 4. Plus 4. We have that 2, 2, 3, 1. So, 2, 2, 3, 1. So, simplify, we have 2 times 4 less 1 times 6, 1 times 6 minus, this is 0, so 0 plus 4, 2 times 1 minus 3 times 2. Therefore, we have 2 times negative 4 is negative 8 minus 6 plus 4 times 2 minus 6. So, we have negative 14 plus negative 4 times 4 is negative 16. Therefore, the determinant of A is negative 14 plus negative 16 is negative 30. We can also solve the determinant of A by using our calculator in a simple way. So, mode, matrix 6, let's say matrix A, 1, and it is a 3 by 3, 1. So, 1, 0, 4, 2, 2, 6, 3, 1, negative 4. AC, shift matrix, number 7, determinant, shift matrix, matrix of A. So, we have, determinant of matrix A is 30. Using our calculator, determinant of matrix A is negative 30. Same with the long method. Number 3, compute the determinant of x. X is 4, negative 1, 2, 3, 2, 0, 2, 1, 10, 3, 0, 1, 8, negative 2, 4, and 6. So, to solve this, I use pivotal element method. And I set 4 as my pivot, but this must be 1. So x, bring out 4, we have 4, 1, negative 1/4, 2/4, and 3/4. And copy the others. 2, 0, 2, 1, 10, 3, 0, 1, and 8, negative 2, 4, and 6. So, I set this 1/3 matrix as my matrix C, and 3/1 I have matrix B, and the remaining others 3/3 matrix is matrix A. This is 1/3 and 3/1. So, to solve the determinant of x, 4 times the 1 raised to row 1, column 1, so 1 plus 1 times the determinant of matrix A less matrix B, matrix C. So, in our calculator, we have mode matrix 6 and the first matrix A, so 1, 3/3, so 1, have 0, 2, 1, 3, 0, 1, and negative 2, 4, and 6. AC, shift matrix data 2, and next matrix B, so we have B, 2, and it is 3/1, so 3. We have 2, 10, and 8. AC, on shift matrix data again, and now matrix C, number 3, and it is 1/3, therefore 1. We have negative 1/4, 2/4, and 3/4. So easy. Therefore, to solve for the determinant of x, we have shift matrix determinant 1 raised to 2 is 1, so just don't input that. Determinant of matrix A, 3 less matrix B, 4, times matrix C, 5. 0. So, determinant of x, we have 4 times 1 times 0. So, determinant of x is 0. Number 5, if A, 3, 1, 2, negative 2, negative 1, 0, 0, 2, negative 1, then what is the cofactor of the first row, second column element? So first, let's define what is cofactor. Cofactor is the signed minor determined by Aij equals negative 1 raised to I plus j mij. So I is the row, and j is the column. So let's start. We are required to find the first row, second column. So cofactor of first row, second column, we have first row and second column. Therefore, it is equal to negative 1 raised to ij first row plus second column times Mij is negative 2, 0, 0, negative 1. Therefore, E12, cofactor of first row, second column is negative 1 raised to 3 is negative 1. And negative 2 times 1, positive 2 minus 0. Therefore, if A12, cofactor of 1, 2 is negative 1 times 2 is negative 2. Number 6, what is the transpose matrix of A? A is 3, 1, 2, negative 2, negative 1, 0, 0, 2, negative 1. So, what is transpose matrix? Transpose matrix is if A is on M by N matrix, then A transpose is an N by M matrix. So, A is in M by N, so A, B, C, D, E, F, G, H, I will become, from here, N by M. So, A transpose is A, D, G, B, E, H, C, F, I. So, A transpose is from A, B, C, A, D, G. So, 3, negative 2, 0. 3, negative 2, 0, B, E, H. 1, negative 1, and 2, 1, negative 1, and 2, and 2, 0, negative 1. Therefore, transpose matrix of A is 3, negative 2, 0, 1, negative 1, 2, 2, 0, negative 1. Number 7, if A is 2, 1, negative 1, 3, and B is negative 1, 2, 1, 1, find A and 2B. So, A plus 2B is equal to A 2, 1, negative 1, 3 plus 2B negative 1, 2, 1, 1. So, 2, negative 1, 1, 3 plus distribute, we have negative 2, positive 4, 2, and 2. Add, therefore, positive 2 minus 2, negative 1 plus 2, 1 plus 4, and 3 plus 2. Therefore, A plus 2B is equal to 0, positive 1, 5, and 5. Number 8, given the matrix equation, solve for x and y. So we have 1, 3, 1, 2, x, y to 0. From this matrix equation, we can form two equations. And using Kramer's rule, we have ax plus by equals ef, cx plus dy equals f. So we have x plus y equals 2, 3x plus 2y equals 0. This is 1 and this is 2. So to solve for the value of y, we have EB FD over AB CD. Therefore, we have EF 2, 0, 1, 2 over 1, 3, 1, 2. So, x is 2 times 2 less 1 times 0, 1 times 2 less 3 times 1. Therefore, 4 less 0 over 2 less 3. 4 over negative 1. Therefore, x is negative 4. And to solve for y, we have we have AE CF over ABCD. So, AC 1, 3, EF 2, 0, we have AC 1, 3, and BD 1, 2. Therefore, we have 1 times 0 less 2 times 3 and 1 times 2 less 3 times 1. Therefore, 0 less 6 over 2 less 3 is negative 6 over negative 1. Therefore, y value is positive 6. And another way in solving the value of x and y is using the calculator in a simple way. So we have mode equation 5 to equation 2 unknowns, therefore 1. So input the value, we have 1, 1, 2, and 3, 2, and 0. So x is 4. From this equation, x is negative 4. And y is positive 6. So, using short method and the long method. Number 10, evaluate the inverse matrix A. So, A is cosine theta. Take 3. Number 10, evaluate the inverse matrix of A. A is cosine theta, negative sine theta, cosine theta. So, from A, B, C, D to A inverse is 1 over determinant, D, negative B, negative C, and A. So, A, therefore, 1 over D, D, negative B, negative C, and A. So, let's find first the determinant, which is top left times bottom right. So, cosine theta times cosine theta is cosine squared theta minus sine theta times negative sine theta. So, cosine squared theta, negative sine theta times negative sine theta is positive sine squared theta. And this is equal to 1 from our trigonometric identities under Pythagorean relation. So, our determinant is 1. So, A inverse is 1 times D cosine theta, B, negative B, so positive, and negative sine theta, and A is cosine theta. Therefore, A inverse or inverse matrix of A is cosine theta, negative sine theta, and cosine theta. Number 11, find the quotient of A divided by B if A is 1, 3, 4, 2 and B is 1, 2, 1, 3. So, A over B is also equal to A inverse of B. So, inverse of B is equal to 1 over D multiplied to D negative B, negative C, A. So, let's find the determinant of D. Determinant. So, let's find the determinant of B. We have 1 times 3 minus 1 times 2. So, we have 1. And inverse of B is equal to 1 times D, 3, negative 2, negative 1, and 1. So, A multiplied to inverse of B is 1, 4, 3, 2 times 3, negative 1, negative 2, and 1. So, we have 1 times 3 plus 3 times 1. And 4 times 3 plus 2 times negative 1. And 1 times negative 2 plus 3 times 1. And 4 times negative 2 plus 2 times 1. So, we have 3 minus 3, 12 minus 2, negative 2 plus 3, and negative 8 plus 2. So, A over B is 0, 12, 10, 1, and negative 6. So, the quotient of A divided by B is 0, 1, 10, negative 6. Number 12. Determine the eigenvalues for... Number 12. Determine the eigenvalues of the matrix A. A is 5, 3, 0, 2. So, to solve for eigenvalues lambda of an n by n matrix, first multiply an n by n matrix by the scalar lambda. So first, we have lambda. So lambda multiplied to 1, 0, 0, 1. Therefore, we have lambda 0, 0, lambda. Next, number 2, subtract the identify matrix multiple from the matrix A. So, number 2, A less lambda I. So, we have 5, 3, 0, 2 minus lambda 0, 0, lambda. So, we have 5 less lambda, 5 less lambda, 3 minus 0, so 3. 0, then 2 minus lambda. And number 3, find the determinant. So, number 3, we have the determinant of A. So, we have 5 less lambda, 3, 0, 2 less lambda. So, top left multiply by bottom right, we have 5 less lambda multiplied to 2 less lambda minus 0 times 3. So, we have the determinant of A less lambda I is 10 less 5 lambda less 2 lambda plus lambda squared. So, number 4, find the eigenvalues lambda. So, to solve for the eigenvalues, let's set this to 0. So, y squared plus minus 7 lambda, 5 lambda plus 2 lambda, so 7. Plus 10 equals to 0. So, get the factor. We have lambda less 7, lambda less 2 equals 0. So, lambda less 7 equals 0. We have lambda equals 7. And lambda less 2 equals 0. We have lambda 2. So, the eigenvalues for matrix A is 7 and 2.